How AI training works. How a computer learns without being taught step by step. When you use an AI tool, it can write text, recognize images, or answer questions in seconds. It can feel like the system already knows everything. But AI systems are not programmed with every answer in advance. Instead, they are trained using large amounts of data and repeated adjustments over time. In other words, they learn patterns rather than memorize instructions in the traditional sense. So today we are going to walk through how AI training actually works and how a model goes from random guesses to useful results. Chapter 1: What AI training means. AI training is the process of teaching a model to recognize patterns in data. Instead of writing explicit rules, developers provide examples. The model analyzes these examples and gradually improves its predictions. The goal is not to store exact answers, but to learn relationships within the data. This allows the system to handle new inputs it has not seen before. Chapter 2: The role of data. Data is the foundation of AI training. This data might include text, images, audio, or other forms of information. For example, a language model is trained on large collections of written text. An image model is trained on labeled images. The more diverse and relevant the data, the better the model can learn patterns. Chapter 3: Models and parameters. An AI model is a mathematical structure that processes input data and produces output. Inside the model are parameters, which are values that influence how it makes predictions. These parameters start with random values. Training is the process of adjusting them so the model produces more accurate results. Large models can contain millions or even billions of parameters. Chapter 4: Making predictions. During training, the model receives an input and produces an output. For example, it might try to predict the next word in a sentence or classify an image. At the beginning, these predictions are often incorrect. That is expected. The model is essentially guessing until it learns better patterns. Chapter 5: Measuring error. After making a prediction, the model's output is compared to the correct answer. The difference between the prediction and the correct result is called the error. This error provides a signal that tells the model how far off it was. The goal of training is to reduce this error over time. Chapter 6: Adjusting the model. To improve its predictions, the model adjusts its parameters. This is done using mathematical techniques that determine how each parameter contributed to the error. The adjustments are small but repeated many times. With each iteration, the model becomes slightly better at making predictions. This process continues until the model reaches an acceptable level of performance. Chapter 7: Training and iterations. AI training does not happen in a single pass. The model processes the data many times in cycles known as iterations. Each cycle allows the model to refine its understanding of patterns. Over time, the predictions become more accurate and consistent. This repeated process is what allows the model to learn complex relationships. Chapter 8: Generalization. A well-trained model should be able to handle new data, not just the examples it has seen. This ability is called generalization. If a model simply memorizes training data, it may perform poorly on new inputs. Training aims to capture underlying patterns so the model can apply them broadly. Chapter 9: Training resources. Training AI models requires significant computational resources. Large datasets must be processed, and calculations must be repeated many times. Specialized hardware such as GPUs is often used to accelerate this process. Training can take hours, days, or even longer depending on the size of the model and the data involved. To wrap up, AI training works by exposing a model to large amounts of data and adjusting its parameters based on prediction errors. The model starts with random guesses and improves through repeated iterations. By learning patterns in the data, it becomes capable of making useful predictions on new inputs. The process relies on data, computation, and careful tuning to achieve reliable results. Although the underlying math can be complex, the core idea is a gradual process of learning from examples. This has been a mini Leviathan production. If you enjoyed it, check out our other videos. See you in the next one.